the discriminant. What is it? Where is it? Where do we normally find it? So at some point in your GCSE, you would have used this formula. You might have recognized it as the quadratic formula. It is normally used when you're trying to solve a quadratic where you have ax squared plus bx plus c equal to 0, because you'll be solving a quadratic. But one of the things that affects that quadratic, or what happens to it, is what happens inside of that square root. Well, that says a lot. Let's find out some of the things that it says. That b, let's just rephrase that. So that b squared minus 4ac is what we call our discriminant. And this tells us a lot. You might have had a function where when you try to work out the quadratic, you end up with a negative number inside that square root, and then your calculator would have given you an error message because it cannot find the square root of a negative number. Well, if you decide to do further maths, you might find out that that answer is an imaginary number. But for now, let's stay in the real world, not the imaginary world, and just say, for the sake of argument, that the square root of a negative number does not exist. Depending on the quadratic you've got, so I'll write my quadratic again, ax squared plus bx plus c. If this a is a positive number, then our quadratic will look like that. If it is a negative number, then our quadratic would look like that, thereby giving us a maximum value. However, if based on the numbers you've got, your discriminant, so let's rewrite the discriminant. If the discriminant is greater than 0, thereby making it a positive number, then it means that the graph will look like that. Or it could look like that. But the point that we want to make about it is your graph will cut the x-axis in 2 places, thereby giving you 2 real roots. So if we have something like that, then we have 2 real roots. And I thought I should just draw a graph to demonstrate that. If it's greater than 0, you get 2 real roots. If, however, your discriminant turns out to be less than 0 for AC, as in it's a negative number, less than 0, negative numbers exist, so it means that your graph will do something like that or something like that, thereby not cutting the x-axis at all, which means that it has no real roots. So that's something to pay attention to. So let's rephrase what we've just said. If your discriminant is a positive number, it means that we have in our square root a positive number, thereby producing real roots as our answer. However, so positive number, real roots. Your graph will cut the x-axis in 2 places. If it is less than 0, meaning that it's a negative number, then it has no real root, which means it doesn't cut the x-axis at all. And then there's one last scenario that can come about, and that is if your discriminant is equal to 0. Well, if your discriminant is equal to 0, this is what happens to your graph. It just touches the x-axis. It can go that way, or it can go that way. So it just touches the x-axis, and in this place we say it has 2 equal roots. okay? But really and truly, it's got one root. It's just a repeated root, okay? So 2 equal roots is what we say we're going to have. So that's 5 minutes into the video just explaining what discriminants are. Now, let's put it to the test with a simple question, then a more complicated question. Okay, so here's a very simple quadratic equation. And I haven't written down the question, but what we want to do is to find the discriminant, and I'll just write disc for short. Find the discriminant, that's job number 1. And then job number 2, state the number of real roots or imaginary roots. Yeah, real roots or imaginary roots. So we need to state that. Okay, so first of all, what we want to do is make it look like ax squared plus bx plus c. We need to make it look like that first, okay? That means this 10 needs to come over there and merge with that 8. So we'll end up with 9. I don't know why I wrote x. I think I like x better than n. 9n squared minus 3n. When we bring that 10 over, it becomes plus, so then that becomes a plus 2 equal to nothing on that side. So my discriminant says it's b squared minus 4ac. And what we're going to do now is replace the b with that 3, and the a with that 9, and the c with that 2. So this then gives us minus 3 squared minus 4 times 9 times 2, which then gives us 9 minus 72. And then what we need to do is minus the 9 from that, which gives us 63. Well, to be honest with you, I genuinely don't care about that number 63. I don't care what number it is. Actually, minus 63. I do beg your pardon. I don't care about the fact that it's 63. What I care about is if it's a positive number or a negative number. In this case, this is a negative number. And if you remember from our rules, the negative number tells us that this function has 2 imaginary roots. Sorry, it took so long to write the word imaginary, and it was going all sorts of wrong because I was trying to talk and write. Anyway, that's what it tells me. We've got 2 imaginary roots. All right, your time to do a little bit of work now. So what I'm going to do the same for me. I'm going to give you a nice simple function, and let's write that in blue. So we're going to have 4a squared is equal to 8a minus 4. I'm just going to pause the video. Well, you pause the video and have a go. All right. So if you remember the rules, we need to make it look like ax squared plus bx plus c. Make it look like that before we do anything else. So we're going to keep that 4a squared over here. Bring over the 8a, bring over that 4, and we've got nothing left on that side. Now, apply the use of your discriminant, and then all you do is substitute the values in. So your b is going to be that minus 8 there. So that becomes minus 8 all square minus 4 times a times c. There we go. And that will give us 8 squared will give us 64. Minus 4 lots of 4 is also 64, which is equal to 0. And we said when the discriminant is equal to 0, then we have we have one repeated real root. Okay, and that's basically it. Now, for the next and final section of this quick video is now about what happens, or what it looks like in an exam question. Okay, so here's an exam question, and I do beg you to give me to pardon my handwriting. My penmanship is atrocious, I know, but I will read the question out to you. So this says, the equation x squared plus m plus 4, all in brackets, times x, plus 4m plus 1 is equal to 0, where m is a constant, has equal roots. Show that you're going to get m squared minus 8m plus 12 is naught. Hence, find possible values of m. Some very important information here to pay attention to. So, let's highlight some of the important information. Well, obviously, the function is important, and it's important to look at the form that it's in. So, for example, ask yourself, is it in the form of ax squared plus bx plus c? And I would say to you, yes, it is, because the a is the number in front of x squared, which at the moment is 1. The b is this whole bracket here, times x, and the c is this whole bracket there. So, yes, it's in the form ax squared plus bx plus c. The other thing is that the other bit of information they gave us, they said that it has equal roots. Now, what does that information tell us? Well, it tells us that that your discriminant bx squared, minus 4ac is actually equal to 0. That's what it means when it says it has equal roots. So you remember, if it's greater than 0, as in a positive answer, you have 2 real roots. If it's less than 0, as in a negative answer, you have imaginary roots. But if it's equal to 0, you have a repeated root. Okay, it's 2 roots, but it's repeated, or I like to say it's just really 1 root. But nonetheless, that happens when your discriminant is equal to 0. So I will now, in order to prove this here, if you notice it's just got m's in it and no x's at all, which means that we need to find the discriminant and show that the discriminant will give us this. So, and that would not be very apparent in the question, but you have to have all your wits about you and know that that's what's going to happen. So, our discriminant b squared minus 4ac is equal to 0 is what we need to prove. Well, I've already said before, b is equal to that, m plus 4. So, let's put that in. So, m plus 4, all square, minus 4 times a is 1, because it's only 1 in front of the x squared there, times c, and c is 4m plus 1. That all should be equal to 0 because of the equal roots. So that's the c there, and that's it all there. Now it's a matter of expanding and simplifying. So for example, here now, please do not make the mistake and say that this is m squared plus 16. You must expand this. I will just give you a hint as an aside. This here, when you expand it, should be m plus 4 into m plus 4. So you need to expand it properly, okay? All right, sorry about the green. So anyway, we now have m squared plus 8m plus 16. So when you actually expand this as 2 brackets multiplying by each other, you're going to get m squared plus 8m plus 16. And then now we sort out what's going on over here. Ignore the 1 because it's really just minus 4 times that bracket. So that's going to give us minus 16m minus 4 it's still equal to 0 on the side over there. And now we simplify. M squared will be on its own, but if we do the 8m, take away 16m, we get then minus 8m. And then once we sort out that minus 16 and that minus, actually, sorry, I pointed at the wrong thing. This plus 16 here and that minus 4, we're going to get 12, because this will be 16 take away 4 equals 0. And this is part A of the question, as you can remember, now answered, because they said show that you're going to get m squared minus 8m plus 12, and we've shown that here. Obviously now when they say find possible values of m, all you do need to do is just solve that. And obviously, because you are a very, very good mathematician, we may try to factorize this, which it can be factorized. I'm not going to go into that. If you don't know how to factorize, check out my video on factorization of quadratics. But here we know we're going to have a couple of brackets now. M. We want 2 factors of 12. That was going to give us minus 8. And that's going to be minus 6 and minus 2. Which is going to give us minus 8. And then now the suitable values of m would be m is equal to 6 and m is equal to 2. So if you want your function to have repeated roots, if you then go back to the top here and change m to 6 and m to 6 there, and you work it out, you're going to have a repeated root. Or if you change m to 2 and m to 2 there and you work that out, you're going to have a repeated root again. Okay, so that's basically it, guys. And obviously, as I like doing these days, I'm going to give you one to work out and give you a quick 5 seconds to sort it out. Well, pause the video and then we come back and see how you did. Okay, here's your one. So in case you're struggling with my penmanship again, sorry about that. It says find the values of k for which the equation x squared minus 2 times k plus 1 x plus 2k squared minus 7 is equal to 0 has real roots. Values of k is what you've been asked to find. You've been given the equation and you need to find it when k has real roots. Okay, so I'm just going to pause for 5 seconds, giving you some time to pause the video and have a go on your own. Okay, I hope you did pause it and you did have a go on your own. Now, let's go work it out. So step 1, as I always say, see if the function is in the form ax squared plus bx plus c. Well, it is, because, and now I'm just going to circle bits in red. A is 1, so it's going to be the number in front there. This whole thing here, including the negative, is my b, and this whole thing here is my c. So as you can see here, you got the minus 2k plus 1 times x, so that's my b, it's the coefficient of x, and the constant on the end, 2k squared minus 7, is there. So that's important. The other thing that's important is that it must have real roots. Well, if it has real roots, what can you remember about our discriminant? Well, you should remember that b squared minus 4ac needs to be greater than 0 for it to have real roots, which means that now we've got, we're going to end up with some sort of an inequality, a quadratic inequality at that. Okay, now we need to get our delicate gloves out and sort this out. Let's substitute everything. So b squared minus 4ac is greater than 0. Let's go. Your b is going to be minus 2k plus 1 in brackets there, and all of that needs to be squared, minus 4 times a, which is 1, times c, which is 2k squared minus 7. For now, I'm going to treat that as an equal to 0, and you'll find out why later on. So let's sort out this little issue here. Here is a nice place for people to make mistakes. Don't make any mistakes here. All you need to do is square this minus 2, so it becomes a positive 4. And as I've said earlier in the video, when you square this bracket, don't just say that the answer is k squared plus 1. You need to expand it by multiplying it by itself. So if you multiply it by itself, you're going to have k squared plus 2k plus 1. And then let's deal with what's going on the end here. Again, ignore that 1. Just multiply the minus 4 out in that bracket there. And that becomes minus 8k squared plus 28. And let's, like I said, put it equal to 0 for now, even though we are working with an inequality, which we will come back to at the end, okay? So we're just using the equal just for now, just so that we're not bothering too much about the inequality. Let's carry on simplifying here. So this becomes 4k squared plus 8k plus 4 minus 8k squared plus 28 equal to 0. We can merge this k squared with that k squared, thereby giving us minus 4k squared. We can, is there anything else we can do? That 8k has nothing to be merged with, so we'll just have the 8k there. And then finally, we have got this 4 and that 28, which is going to bring us to 32, and that's going to be equal to 0. Now, before I attempt to solve this quadratic, notice all these numbers are multiples of 4. Always a good idea to try and simplify things. I'm going to divide by minus 4. And why minus, you say? Well, as a personal preference, I don't like dealing with minuses on the front here. So if you want to work with it, that's fine. I just don't like working with it. So anyway, here we go. Dividing by that minus 4 gives us k squared minus 2k minus, yes, that is minus again, 8 is equal to nothing. And then now I solve. Well, we'll jump straight into what goes into the brackets, which will give us a k there and a k there. 2 factors of minus 8, that's going to give us minus 2, would be minus 4 and a plus 2, which means now that if we were to plot this on a graph, because I divided by minus 4, the graph now looks like that. And it cuts the x-axis at, well, minus 2 there and a plus 4 there. It's plus 4. So therefore there's a 4 there and a minus 2 here. Now let's bring that inequality back in. This was meant to be greater than 0, yes? Yeah, greater than 0. Greater than 0 means that we're looking for the part of the graph above the x-axis, which means that we want that region out there, this region out here, which means you're greater than 4 and you're less than minus 2. So the values of k for which this function has real roots is when k is greater than 4 and when k is less than minus 2. And this is now finished. So I hope those are the 2 answers that you've gotten. Look out for questions like these in your exams. Well, good luck, guys. This was brilliant. It was fun. I hope that you learned something from it, and see you on the next one.